And Assalamualaikum to my fellow lecturer. So my name is Nur Najwa Amani binti Norman, and today I will present to you about my final year project titled The Development of Wireless Neural Lie Detector. I am a student from 3B section 1/1, and my supervisor is Encik Khairul Azhar bin A. Aziz. Okay, so as for today, the presentation will be in 8 subtopics, which the first one is the introduction, continues by the objective, project scope, problem statement, literature review, methodology, expected output, and finally, we will talk about the conclusion of this project. So we go to the introduction, the first chapter, which in introduction, in this era, the lie detectors is a commonly used tools to detect liars. So there are varieties of lie detectors which uses the blood pressure, pulse, skin conductivity, fMRI, and also image processing. Besides, there are also a lie detector that uses sensors such as ECG and EEG lie detector. There are many method changes made from decade to decade, where from measuring emotional disturbance in the early 90s to image processing from human pupils in 20s. Thus, it did not just end there. Many other tools and sensors are made to detect liars nowadays. Investigators use lie detector to find the villain from their investigated case where Q&A method is used. This is an open-ended question where the answer only consists of yes or no. So most of the lie detector uses MATLAB and polygraph, which was connected with varieties of microcontrollers such as Arduino, EXP32, and also the PIC. So we continue to the objective of this project. So there are 3 objectives, which are the first one is to develop a wireless neural lie detector. Then, classify the features of EEG signal for lie detection, and lastly, to analyze the performance of the EEG system. Next slide, we show you about the project scope. So the first project scope is to develop a prototype of a wireless neural lie detector by using only the EEG headband sensor. That is to make the most reliable, user-friendly lie detector that can be used not only for authorities but also for the locals. And finally, it contains a simple, understandable method which are mostly being used from the past researcher. There are a few problem statements that has been found, which is most of the past researcher uses a sensor with tons of electrode placed on the scalp, where this project is to make a lie detector by using EEG headband, which is this product is stated as more compatible and user-friendly product. Okay, so next, most of the EEG system uses a large value numbers of electrode, but this sensor only consists of 3 electrode, which is being placed at the frontal lobe, central lobe, and parietal lobe. Then, finding an EEG signal directly is not an easy option, as the signal contains numerous numbers of noise. Therefore, only the best method is being chosen for this project. So lastly, most of the past researcher has no appropriate ways in showing on how to connect the EEG headband to the PC by using Arduino as a microcontroller, and make finding of the EEG data by using only the MATLAB software. Therefore, this project will show all the method used accordingly to the stated procedures. So we are now for the literature review. Okay, so the electroencephalography, or is known as EEG, is made by a German psychiatrist named Hans Berger. So he discovered the alpha wave rhythm, where it is called as the Berger wave. So it is stated that the EEG is a technique used to monitor the electrical activities of the brain, where this happens when the electrical impulse will generate because there was a communication links between the brain cell. Okay, so here we are in the brain examination. So there are 3 electrodes used in this project, where it is placed at the parietal lobes, temporal lobes, and also the frontal lobe. So each lobe has its own characteristic, where for the parietal lobes, it's for intelligence, reasoning, telling right from left, language, sensation, reading. So next, the temporal lobe acts as accordingly to the speech, behavior, memory, hearing, vision, and also the emotion. So last but not least, the frontal lobe is for movement, intelligence, behavior, memory, and also the personality. So this slide will show you about the brain-computer interface, or are known as BCI, where it has three types, which is invasive VCI, partially VCI, and non-invasive VCI. So as for this project, we uses the non-invasive, where the brainwave sensor is placed outside the skull or specifically on the skull. Okay, so the BCI allows humans to interact with their surrounding without the involvement of peripheral nerve and muscles by using control signal generated from the EEG itself. Okay, so we continue the slide with the types of EEG wave. So we are using 5 types of wave for this project, which is the delta wave, the theta wave, the alpha wave, the beta wave, and also the gamma wave. So each wave has their own frequency, which is for delta wave 5 Hz maximum, theta wave 5 to 8 Hz, alpha wave 8 to 13 Hz, beta wave 13 to 30 Hz, and finally for the gamma wave 34 and above. So each frequency is very unique if compared to each other. So these are the most popular and common types of questions that are used in the lie detector of the EEG sensor. So the first one is the GKT test, which is known as the Guilty Knowledge Test, which is this question is based on a visual such as details of familiar item that has been used or has been seen at the crime scene. So this is used to examine whether the offender has any knowledge about the crime or no. So next, the control question test, or known as CQT, typically an open-ended question which consists of answers only a yes or no. So this question is quite similar to those being investigated, but it happens in their past. We go through the methodology of this project. Okay guys, so as you can see, below shows the project Gantt chart of this semester. So the first week started with finding suitable projects and also the project titles. Continues by the chapter 1, which is the project background, project scope, objective, and also the project problem statement. So as for the second and third week, it starts with reviewing research paper and find all the sources accordingly to the topic that we have chosen. Week 3 also completes by plotting the literature review of this project. So within week 3 and week 4, we are finding the best software to use in this project, and continues by designing the block diagram and process flowchart of the project in week 5 to week 7. So starting for week 8, we continue with the preliminary result and expected output. Also, find the commercialization relevancy of this project. Week 11 to week 12, we make finding and attach the conclusion of this project. However, editing the project is done almost every week. So the project block diagram of this project started when the data is collected and recorded by the sensor. So Arduino that acts as a microcontroller will transmit the data by using the USB port connected to the PC. Then the PC will open the MATLAB software, and the MATLAB software will do most of the tasks in this project. So the data signal pre-processing is used as a data filtration. Next, the feature extraction process, where the process uses a filter bank to reconstruct the signal. Lastly, classifier will classify the data and make findings of the output. After completing all the MATLAB tasks, so the MATLAB will also represent the output, where it will show either the person is lying or not accordingly to the data that we have achieved. Okay, so for this slide, I will show you about the NeuroSky MindLink EEG headband, which we will be using as a sensor for this project. So it consists of only 3 electrodes, which are being placed at the frontal, central, and parietal lobes. So the electrode use a dry electrode, where it is a lightweight and is user-friendly headband. It consists of Bluetooth module and support both iOS and also Android system. The weight of this product is around 45 grams, where the battery is made up from lithium ion, where it can stand around 2 hours. Okay, so Arduino Uno will be used as the project microcontroller. So it consists of Arduino Integrated Development Environment, which is Arduino IDE, and also Arduino Support Package to bring all the data from Arduino to MATLAB software. So the Arduino will be connected with wire jumper from the Bluetooth sensor with USB connection to the PC. So Arduino support package help in finding analog and digital sensor data from the Arduino board. This slide will show you about the HC05 module. Okay, where this is a high-performance Bluetooth module for the sensor where it allows in achieving the highest level of sensitivity and accuracy with the lowest consumption. So the connection of this module is the HC05 will be connected with the EEG using Bluetooth, and this Bluetooth module will be connected to Arduino by using wire jumper. So the connection will connect the VCC, GND and TX from HC05 module to pin 5V GND and RX to the Arduino Uno. Okay, so next we continue with the project flowchart. So firstly, the EEG sensor is being placed at the subject scalp. Then, the GKT question is being asked. So when the Arduino Uno receive the data will be imported to the MATLAB software by using the Arduino support package. Then, all the data will be processed in 3 stages, which is the signal pre-processing, the picture extraction and also the classification. Then, after this all completes, the output will be achieved and will be shown also at the MATLAB software. So this is the type of question that we have chosen, which is the GKT question. So there are 3 stages of question, which are the truth question, lie question and lastly the baseline question. So all the subjects will also be given each one of them a card that consists of numbers and colors where they will ask to not reveal their cards by giving the correct answer to the questionnaire. Okay, so for the first question are the truth question, where the subjects were asked a simple question about themselves, such as their name, where do they live and also their occupation. Then for the lie state, the subject have to make objection and never let anyone know the color and the numbers on the given card that they have. Alright, so lastly, the baseline question, subjects are needed to relax and stay silent. In this stage, no question and answers are needed. Okay, so these are the flowchart of the MATLAB software, where in the left side, it shows the EEG processing system in MATLAB. So it starts with the EEG signal, alright, and continue by the signal pre-processing, feature extraction, and finally the classification. On the right side, shows the overall MATLAB flowchart that are being used in this project. So for the MATLAB software, the first part is for signal pre-processing, which is it filter data after the data has been recorded. Okay, so each data will be filtered and inspected using the band pass filter, which is actually a combination of low pass filter and high pass filter. Okay, so the band pass filter is actually we use directly with the DWT feature extraction, as the scaling function were quite similar to the low pass filter and the wavelet function is similar related with the high pass filter, where it decomposes the signal starts by passing through the band pass filter. Go through the feature extraction. So DWT method uses a multi-filter band and special wavelet filter where it divides the signal into various spectral components which are also being called as the sub-band coding. So it produces 5 characteristics of the P300 signal, which are the minimum amplitude, maximum amplitude, mode amplitude, median amplitude and also the mean amplitude. Okay, there is no useful frequency up to 30 Hz. Okay, so thus this method only chooses 5 signals and be in a group of D1, D2, D3, D4 and D5 and approximately signal of A5. So this is called as Daubert's wavelet filter. Okay, so the EEG signal characteristic extraction is obtained by the decomposing the signal up to 5 level using the discrete wavelet transform, which is the DWT. Besides, the Nyquist theorem is also being used in this project. Lastly, for the MATLAB software is the classifier. So the SVM method is chosen as the classifier. So this method finding that it produces high accuracy if compared to other types of method. Okay, so this method uses by finding the separation between the two classes, which are the distance between the hyperplane and the closest point from both classes are minimum. So the plane with the highest margin is the objective of this method. So the SVM also developed the decision hyperplane by the distance of separation between the output classes of data. So the binary set will classify with the linear and RBF kernel, where it allows the LIB SVM library to classify it. Okay, so this is the expected output that we want to achieve in this project. Okay, so it came from the raw data, go through the bandpass filter, the DWT feature extraction, the SVM classifier, and finally the output will be on MATLAB. Okay, so this neural ID title will be a success product if the method and procedure is done correctly. So therefore, this product is very convenient and user-friendly, where it was created not only for authorities but also for every citizen. So this product can be used for the user not only to detect lies but also as a learning process to study about the brainwave. This is the last slide, which is the conclusion. As a conclusion, we managed to find all suitable ways in completing this project from the research that we have done from the previous chapters. So, we are able to construct and make findings in ensuring the preliminary result will be achieved as the expected result. As all the flow is stated and method also procedures is made, we are able to arrange in making a troubleshooting for this project if there is an error that occur. So this project can be useful to others as it may help all the people that were stated in the project scope. So that's all from me. Thank you so much for listening. Goodbye.